of the VOR. My goodness. Anyway, guys, back to VORs. Again, my guess is some of you have probably watched that video that we did before again. You're going to have to do this, and that's going to apply for everything that we do going forward. Everything that we do now certainly is going to be more complex than anything that you've done. And so it's going to be the thing where you're probably going to have to watch these videos more than once. It's just the way it is. So here we go. Back to the action. So remember on the VOR is going to be, and let me, pardon me whilst I draw for you, that VOR, it's going to be this station, this radio station that is in the center, and it's sending out all of these different channels that we call radials. And all of those radials emanate from the center of that station. Those radials correspond with one of 360 degrees that make up a circle. And remember this as well, this example, and I wish I could draw a straight line. From the center, this radial is the 090 degree radial. Likewise, from the center here, this radial is the 270 degree radial. Yes, it's a straight line, and it may be the same course, but it is a different radial once you pass the hub or the station. So if you want to think of it in terms of spokes, God bless. But these are radials, okay? So that's what they are. When you pass that station, you are on a different radial, even though you may be going the same direction. So you just keep that in mind. When you pass that station, you're now on a different radial. Okay? Got it? So another way that you can use these VORs is kind of like this. Let's say, for instance, that you're using a VOR and you're coming to the VOR, but from the VOR, you're going to be going a different direction. So let's say that you're headed to the VOR, you're on the 090 degree radial, and you're tracking to the station using the omni-bearing selector or your course selector for your radial as 270. Remember, to the back. So whatever is on the back side of this VOR, that's what you're tracking to, okay? So go to the back, right? Then you can also use the VOR to track away from the station. So let's say, for instance, you're on this radial going to this VOR. We'll call it the ABC VOR. Remember, all VORs have a 3-letter identifier. So this is the ABC VOR. And at the VOR, you're going to change your course. You now want to go kind of roughly southwest. So you want to go to the back to get to this station, to the back to 270. At the station, you're going to change your course, and you want to use the 240 degree radial outbound, okay? So in this case, as you make this turn, you're here at the station. Now you're going to select this 240 degree radial. Let me clean that up a little bit. That just didn't look real good. This 240 degree radial outbound. Remember, to the front, I'm sorry, good Lord, stand by, hang on, I screwed that up. To the back, goodness, to the back, from the front. So in this case, we're going to track away from this VOR, and we're going to change the course setting in our omni-bearing selector from 270 with a 2 indication. Now we're going to use to 40 with a from indication to track away from this station. Okay, so that's how you would use that. Okay, that's that thus far. Let's press on here with this and we'll try to confuse you some more. So with this, stand by here. Why isn't that moving? There we go. So if you look at this picture, what you'll see there is that you're going to see a picture of a VOR circa 1953. Let's take a look at something a little more modern, shall we? This is what a VOR looks like. When I was a kid, out and growing up in western Kansas, out in the Plains states, I would see these things out there by the highways or someplace off country roads, wherever I was, and I'd see them and I'd think, wow, is that a missile silo? Yeah, I know. So that's what a VOR looks like. You've got this building, and inside this building you have all of these transmitters. Remember, these transmitters are transmitting that one station, and they're transmitting 360 channels or radials. But that's what one looks like. They come and they look a little different, but the FAA has, they're actually, on some of these VORs, they're shutting them down all the time. If a VOR has a problem and it needs a lot of maintenance on it, they're just shutting it off because they're, like I say, they're getting rid of them. But while we have them, we're going to use them. So the antenna, it can look a little different on different airplanes, but that's what it looks like on a Cirrus. That's your VOR receiver antenna. How a VOR works. So again, remember, it's a VHF radio signal. You've got two different things going on here. So it's kind of two overlapping signals, or in some cases they're overlapping. You have a reference phase and you have a variable phase. Okay, the reference phase, this is that thing that goes out omnidirectional, that goes everywhere. The variable phase, this is going to be that thing that is going to basically identify the actual radial itself. So if you look at something here at 360 or 0, the reference phase and the variable phase are going to be the same. They're going to be opposite here, these sine waves that you see here. So they're going to be opposite. They're going to be 90 degrees off here at 90 degrees, 90 degrees off here at 270 degrees. But just understand that there's like two different signals going on here at once in order for you to actually use this station. One that talks about and identifies the station itself. The second one is going to be that thing that identifies the radial. So that's what you use for your Omni bearing selector once you get the actual station itself identified. When we look here also, it also sends out a signal that is a Morse code signal. Morse code signal helps a pilot identify the right VOR. But remember that in the G1000, ours is a little bit different. So in this, we actually have a way of identifying that signal that makes it a little bit different than tuning in to the actual communications side of this and listening for the right Morse code. That's one thing that you're going to see in those blue boxes by the VORs, whether you're looking at a sectional map or whether you're looking at one of the low altitude charts, which we're going to be bringing, by the way, with you to class. So make sure you start bringing your VOR charts, Make sure you start bringing, goodness, your sectional maps as well as your low altitude charts. So bring those. And remember that one of the things that happens is that you can listen to the Morse code to make sure that you're tuned into the right VOR, or in the case of the G1000, remember I told you that if it's picking up the right station, you're going to see that right here. You're going to see the actual 3-letter code, and if it's green, it's good. Okay? That's flashing. We'll get rid of that. So if it's green, it's good. So there's 112.8 EMP, Emporia, Kansas, and that's showing you here from where your current location is. If you were to turn left to a heading here of 223 degrees and recenter your CDI, that would take you directly to that VOR. And then you'd have to kind of make your adjustments with regards to windage, etc., etc. So another thing that will happen here, some of the VORs will actually broadcast a weather information voice recording or a computer recording of some of the weather along the way. They have kind of stopped doing that at a lot of these here because, again, it's like, you know, when this equipment goes down, they just don't spend the money to replace it because everybody is using GPS, or that's where they're trying to go. So that's one of the things that happens. So just know that when you see things for high WAS or even the AWAS here, that you're going to see that you'll see an actual a code there that will tell you that there's a high WAS broadcast from that particular VOR to give you some weather information. High WAS, it's a hazardous in-flight weather advisory service that is out there for any form of like hazardous weather. Distance, this is going to be something that you guys are going to need to know. Now, clearly, a radio signal is not going to be able to broadcast across the nation. It has limits. It has limits of where it will actually be able to get picked up, but then it'll also have a limit as to when that signal is strong enough to be useful to you. Remember, radio is line of sight. Also, with this, you know, even with the curvature of the Earth, and that's, you know, clearly exaggerated there, you have to kind of know that you need to be above a particular angle here in order for you to receive information from that VOR. So you can look at this and you can kind of range this here, and you can kind of see that theoretically you should be able, if you're 7,000 feet above this VHF range, you should be able to pick that up 100 miles away. But not always. There are certain VORs that are standard service, that have standard service volumes that limit them. You're going to need to know these. You've got three different classes of these VORs. You've got a high altitude, a low altitude, and a terminal VOR. So when you're looking at these, you're going to need to know what are my broadcast ranges, and it has this here on this chart. So you can see the high altitude one, and you can see that it expands quite a distance here from the center. Okay, so here with the low altitude ones, which are most common, you're really not going to be getting much until you are about 40 nautical miles away from the center of this station. That means that from the beginning to the end of this station, it'll be useful to you for about 80 miles. The terminal ones, these are ones that are primarily located, for instance, at airports. They're actually going to have even a smaller range here as well. Now, these high altitude ones, notice the shape. So you can see here is that you've got 40 nautical miles here, and then you have 100 nautical miles here, 14,500 feet AGL, and then at 18,000 feet AGL, where Class A airspace begins, is that it's going to be 130 miles is where you'll be able to pick that up from that station. So again, this would provide the high altitude station 260 nautical miles of guidance for you if you're in Class Alpha airspace below 45,000 feet. Class Alpha airspace goes from 18,000 feet to 60,000 feet. Okay? So you're going to have to know this, know the standard service volumes for each type of the VOR. Minimum en route IFR altitudes. Remember what this is. A couple of things have to happen here to meet the MEA, or the minimum en route altitude. It has to meet obstacle clearance requirements, and it also has to be high enough to give you acceptable navigation signal coverage between these particular fixes. So that's where these MEAs get established, minimum en route altitudes. Then also, remember, we have these things called MOCAs, minimum obstruction clearance altitude. Just because you have a MOCA doesn't mean that you're going to get receiver information from the VORs. Because of this is going to be some of these obstacles. Remember, this is a VHF signal and it's line of sight. So if you have things obstructing the line of sight, you're going to lose the signal. So here at the MEA, you get not only obstacle clearance, but you also get navigation reception. Here, you're going to clear the obstacles, but you're probably going to lose your VORs. So you have to plan for that. So here's that. A VOR changeover point. This is one of those points here. And are they going to show what it looks like? Yeah, it kind of does. So when you're tracking between VORs, for instance, if you're flying from one VOR to another on Victor Airways, when you look at those sectional maps and you look at those low altitude VFR charts and you see those little blue lines between the VORs, those are Victor Airways. Victor Airways are Class Echo airspace. They are 8 miles wide, or as the FAA likes to say, 4 nautical miles either side of the center line of that Victor Airway. They have numbers on them, and you can actually use those numbers in your flight planning sequence to identify which Victor Airway you're going to use to go between one VOR and another. At some point on these charts, especially on the low altitude charts for your IFR work, you're going to see a changeover point. A changeover point is where it's recommended that you switch from the guidance from one VOR to the other. So you'll need to tune in. In this case, what they're showing is that here you are on this VOR called VORTAC 1, and there's your frequency, 117.00. At your changeover point, which is going to be something that's going to look kind of like this, that's going to be your changeover point. It's a little thing that kind of looks like that. And at that point here, wherever that, well, that looks more like a swastika. We're not going to go with that. But that's that changeover point. So it's normally about halfway between the two. In some cases, it may be a little bit more than halfway or not quite halfway. Depends on kind of terrain there also with reception. So at this point here, at the changeover point, this is where you would change over to the next frequency of 114.05, so that now you have been tracking, in this case, you have been tracking away from this VOR, so with the from indication. Now you're going to pick this up here with this new VOR on the new frequency, and you're going to go to that VOR with the 2 indication. So that's kind of how that works, okay? So you can see here from and to. Got it? Okay. Now then, here, VORs on aeronautical charts. What we're going to show you here now, these aeronautical charts that you're looking at, this top part, this is what your low altitude charts look like. They don't have all of the topographical information on it because in most cases you're using this is IFR, and so you're on an instrument flight plan. You're going to be above any kind of terrain, so it doesn't show the terrain. It declutters the map. I say declutters the map. It appears to be a lot of clutter on there to me. But when you look at this, you can see that we have a couple different things that we're showing you here. First of all, I'm going to give you this picture. This is going to show you, this is like what we call the NACO type of chart. It's a government chart. And then this one is more proprietary. This is going to be the Jeppesen chart. So when you look at what these VORs look like on a Jeppesen chart versus what it looks like here on a NACO or government chart, they look a little bit different. They give you the same type of information, but it's a little bit different. People that start using one or the other, they kind of stick with that because they kind of prefer it. I've always used the government charts like these over here, primarily because they were a lot less expensive than the Jeppesen stuff. However, now with ForeFlight includes a Jeppesen type of an overlay as well as the government overlay. And it also will show you when we get to the approach plates what those approach plates look like, because the government approach plates do look quite a bit different than the Jeppesen approach plates. We'll show you the differences. you're going to learn how to use both. And that's going to be the thing that you're going to learn. And then when you start doing this for real, you're going to decide which one you like better, why you like using one versus another. And normally that's kind of what you stick with. So there you go. So with this, you can see that you have these Victor Airways here that are marked. So on this one, on MCA here, this is going to be the Linden VOR. You can see that you've got Victor 23 coming out of there, Victor 018 coming out of this. And you can see here that at this particular VOR, you've got a lot of different kind of course changes that happen over this VOR. And this, a couple of things that you're going to look at. I want you to, again, make sure that you use that chart guide, that you can kind of use that as your guide to tell you what all this stuff means, what all these distances means, how to look up the frequencies, understanding what the Victor Airways are telling you. And we're going to be doing more on that here coming up in a quiz near you. Here is AFD giving you information here as well about the VOR. Different types of VORs. A VOR, VOR DME, TACAN, and VOR-TAC. This is going to tell you kind of what the differences are. So you can have a VOR, which is just like a regular VOR. You can have a VOR DME, which gives you distance measuring abilities there. TACAN, which is a tactical air navigation unit here that they use for the military. And then they have a civilian military combo. So the civilian military combo that is most common is what we call a VOR-TAC. A VOR-TAC is a combination of a VOR and a TACAN transmitter. And that's what we use. And if you look actually at the at your guides on your legends for your sectional charts, you'll see what those different ones look like. So you're going to need to know what those are. VOR cockpit instruments. We talked about the CDI, the course deviation indicator, and what that looks like. This is going to be a typical VOR display inside the cockpit. Now again, this is just the VOR display. The box itself, you have to tune that in to the right station frequency in order for anything to happen. So for instance, if we talk about this particular VOR, and remember Emporia, so you have EMP, and I think that was 112.80. That's a horrible looking 2. Pretty lazy. Okay, 0.80. So that's going to be the VOR. Remember, 3-letter identifier there. That is going to be the station itself. The OBS is what you're going to tune, and it will turn this unit here to bring this dial to bring whatever number you want to the top of this box. To the top of that box, that's what you've tuned this to. So remember, you go to the back or from the front. In this particular case, what's happening here is that let's say that you're going this direction away from this VOR. Here's the VOR, the frequency, let's call it 112.8. And then you use your Omni bearing selector to put this course index to choose the 015 degree radial from this station. So you can see here that you have a from indication, and so with this would basically be what that would look like as you're flying away from the station. Okay, so that means this is sort of how this would look if you are on this radial, on course, flying away from this station on the 015 degree radial with a from indication. Now, here's something else I want to tell you. You'll notice that each one of these airplanes is giving that indication. What the heck? Why does that happen? Well, it happens because, remember, you have those VOR antennas that receive that signal from that VOR, and you have a box in there. That box doesn't know what direction that you're pointed. That box doesn't care what direction that you're pointed. The only thing it knows or cares about is, am I on a particular radial? And if I am, here's my CDI. If I'm not, I'm going to show that I'm off one side or the other. That's all it cares about. It doesn't care which way your nose is pointed. It only cares when that box is either on that course or crossing that radial. So on the radial or crossing the radial. It doesn't matter if you're going away, to, from, doesn't matter. All it knows is that that box is at a particular point in space. That's where it is. You have to select your to or from indication, and you have to use your omni-bearing selector or your course selector to choose the VOR, and then use that to choose the radial and use that radial to go to or from that station. That's what you do. So that's where it gets just a little confusing. We'll talk more about that here in just a little bit. One thing also I want to tell you is we talked about these dots. So you remember these dots? Each one of those dots on that CDI represents 2 degrees of course deviation. A full scale deflection of that VOR at the 5 dots means that you're at least 10 degrees off your course. It is bad form for you to be way off your course, especially on an instrument flight plan, because it doesn't take too much for you to get outside the parameters of those Victor Airways. Remember, Victor Airways, Class Echo airspace, 8 miles wide, okay? 4 miles either side of the center line. So you want to try to keep that bad boy centered as best you can. The time when, of course, it's going to be acceptable to have this off and then fix it is if you're intercepting a different course line. We'll talk about that here in a little bit here as well. So you guys can read about that. Okay. Course deviation. So when we look at the deviation here, you can look at this, and there's a thing called a 1 in 60 rule. 1 nautical mile off course in 60 nautical miles equals 1 degree course error. So 2 degrees nautical miles off course in 60 miles equals a 2 degree course error, or 1 dot on the VOR. Oops, hang on, I thought I was drawing a picture. Oops, come here, come here. Oh shoot, hang on, sorry guys, let me get that off there. Goodness. Okay, so with this, it kind of helps to know how far away you are from that station, to know exactly what those dots mean. So that's kind of where you kind of need to look and understand how far off course you are based on which phase of flight that you're in. When you are in the en route phase and you are the greatest distance away from the VORs, it's a little bit different than you are when you're right on top of the VOR. So that's what this is telling you here, is about your course deviation and what that means. Okay. This is solid gold. So understand what that means. All right? to or from. This is what we talked about here before. The displays are going to look different based on a to or a from indication. So let's look at this right here. What this is telling us is that in this particular case, we have right here the 090 degree radial. All right? Remember, using this radial, if we wanted to know that we are using this radial for navigation, we are on the 090 degree radial, but we're using 270 because that is the reciprocal of 090, 270. So that would be 270 with the to indication, to the back. But you'll notice that this airplane is pointed this direction. ¿Por qué? Well, let's say that you wanted to identify when you were flying. Let's say that, I'm going to change this picture here just a little bit. And let's say, for instance, that your course that you're actually flying is going this way somewhere. Well, you have a VOR over here, you got a VOR over here. Let's say that you wanted to identify where you are on this map. You can use these two VORs to find out. If you wanted to know when you're crossing the 090 degree radial, which is this one right there, then you can have this set up with a to indication for 270, and then that gives you the reciprocal, which is 090, and it will give you that you're lined up right there where your course deviation is right in the center, and that will tell you that you're crossing that VOR just like this. Another thing you could do is you could set this up to be able to say, if I wanted to know when I was over that particular spot of Earth, then you could identify this radial here, and let's call that maybe the 250 degree radial here, and you use your second VOR. Oh, well, in this case, it's they're calling that 235. We're not calling it 235, we're calling it 250. So what you could do is you could have your two VORs set up so that you can say, okay, I'm going to cross the 090 degree radial of this VOR and intersect this line here with, call it the 250 degree radial right here. And when I cross that intersection, I know I am right above this spot of the Earth. You can do that. That's pretty cool. It requires some thought. It requires a little spatial orientation, requires a little math, but you can do it to use those as intersecting lines. Just so you know, when I fly, the lion's share of it anymore is GPS. It really is. However, when I'm flying, I have my underlying VORs here, even if I am on a GPS flight plan, which is what this is. Let's just say, for instance, that I want to fly to, let me change this here. Let's say I want to go direct to Kansas City. There's, nope, hang on. There's Kansas, nope, come on. Kansas City. Well, why isn't that there? No, it's not, goodness. There, Kansas City. And I want to go direct to, yep, enter, enter. Now I've got Kansas City right here. This is my course. So if I wanted to fly to Kansas City based on this GPS course, I would turn my airplane to the right to pick up this track of roughly 034 degrees and then keep this course deviation indicator centered as I am navigating this direction to go to Kansas City. Well, underneath it, I want to use my VORs so that I know where I am between some of these VORs. In the event that my GPS signal fails, I can still complete my flight because I know where I am based on the orientation of the VORs. So I have these underlying my GPS signal all the time. I have two of them. I have nav1 and nav2. In this case, there's Emporia. There is a way here, and I don't know how wieldy this is going to be here, but it's not going to be, oh yeah, this one may be kind of tough. I don't know. Yeah, it's not letting me do what I want. But I can use that to dial in two different VORs and track them. VOR 1 has a single barrel line here. VOR 2 is going to have a double barrel line like this. And I can use those two so that I can use those crossing radials of the VOR, whatever it is that I select, to track where I am. And I can always tell where I am in relation to a VOR simply by tuning that VOR, rotating my signal around where I have my CDI lined up, and then where I have that CDI lined up, whatever that radial that it shows me that I'm on, that's it. I'm just on that particular radial at whatever distance it's telling me, just like this. It's telling me here that I am at 68.3 nautical miles here on in this case, if I know that my course is 223, then I need the reciprocal of this. So it's going to be 043 degree radial. I read the tail of my pointer, 043 degree radial, or I use the reciprocal of 223. Minus 2 plus 2, there I go. So 043 degree radial, right? Woohoo! All right, back to this. So now, this is the part that takes a little while to kind of wrap your head around, guys. And that is this part about this whole to or from indication and how to use it. If you're going away from the station here with the from indication, this would be appropriate. If you happen to be going to the station here, like this, again, on this line, if I were, well, let me redo that because that's be a little easier. So if I'm going this way here with the to indication of 270, the old duck on the wall tells me that we have got to our time. With the 270 and the OBS with a to indication, that's also appropriate. You can see here on this as well, on the 235 degree radial of this, how this works as well. So you're tracking to the back, the reciprocal of 235 is going to be 055, going this direction. Okay, 055, with a to indication, tells you that you're on course. You can also track away from this station here on the 235, reading it from the front. So to the back from the front, right? Got that so far? Remember, to the back, in this case 2 is going to be going back here to 055 degrees, or you can use this with a from indication here, like this one, from the front. Right there. What is that? 235. See that? Now you're using 235 outbound tracking with a from indication. All right, there's that. There's going to be 2 more parts to the VOR. There's going to be a part 3 and a part 4, okay? So this is part 2, take 2, and the next 2 parts will be coming up and ready for you this week. Guys, thanks very much. Appreciate you sticking around, and I will see you guys soon. Here we go.